So where it's gonna be saved?
It will be on the iCloud,
Okay.
like on the My State. So,
It's fine.
So are you going to do on this or blank pages?
No, for this I wanna.
Or then you do
Yeah, some of them like this one. Just use this one. Use that one. She said she may be late. I don't know. Everything is good. Whenever you wanna go to the conference. Yeah. So online they're gonna pay me. Let me know anytime I'm off screen like you were doing last time. Yeah, no, she also said if you see me off screen, just let me know. Or you can even see from there. I just saying like that. Let's make a big right? Yeah, maybe it's just let me see. So how do we name the compound? We start by 1, 2, 3, 4, 5. Say again. Okay, how do we name the compound? We have 6 carbon. Yes, ma'am. Oh, I'm sorry. The OH is at first position, yeah? Is 1 here. Yeah, 1 on. So we're naming this, we have a 6 carbon, which will be X, right? So how do we name the compound? We have, we can name it 1, 2, 1, 2, 3. It will be 3-chlorophenol. Remember, we talked about phenol instead of a benzene, so 3-chlorophenol. And then the last one, which is a kind of more complex, but is not if you know how to assign the numbers. The most important thing you have to remember, guys, is how to assign the numbers. That's the most important. So how are we going to name this compound? Let's see, we have 2 substitution, right? And those are the same. Oh, okay, I'm sorry. So how are we going to name this? One, 2, 3, 4, 5, 6, right? At 5 position, we have isopropyl. So we will have 4 ethyl, 5 isopropyl, 2 methyl what? Phenol, right? Does that make sense to you so far? So if there's no question for the question number 1, let's go to question number 2. This is the easiest one. They ask you to keep the intermolecular force between those molecules. So if you see the first one, this is just simple cyclohexane. There is no polarity, there is no electronegativity. So you have to figure out if the molecule is non-polar or it doesn't have any OH or any electronegative element. So what is the force predominant? The dominant force will be what? Dispersion. Right? And then the next one, as you can see, this molecule can be polar. We have a dipole interaction because this one can have 2 different dipole. So, and that one we will see what is dipole force, right? The next one, this is the very important interaction force, is do we have an OH group, and OH is a special dipole force. So it will be H bonding, right? Hydrogen bonding force. Any questions so far? Online, guys, do you have a question? Can you hear me? Okay. Okay. Okay, question number 3. So question number 3 will be the easiest one. So if you did go through your note, I mean it's like a slide 4 or 5 in your PowerPoint note. So they're giving you the PK. Oh, sorry. So they're giving you the PK of different molecules, and then the thing you have to remember is that the smallest, let's say this, you have a small K means like large PK, right? And then large Ka, small PK. And then if you see the question, they already gave you the PK of each compound. So what you have to keep in your mind is that the reaction is going from more acidic to less acidic, right? And then from your PK number, you can say which one is less acidic and which one is more acidic. Does that make sense? So large PK means what? Less acidic. So is you don't have to think twice. You just put your narrow. It's gonna go from small PK, which is more acidic, to large PK, which is less acidic. So that's the reaction is going through right side. So look at the second compound. We have a PK of 18 versus PK of 15.7. So ask yourself which side the reaction is gonna go, right? Because you say what less acidic is favored, so it's gonna go this side. So the next one, you look at your PK again. We have 7.5 versus 9.2. It's straightforward, so the reaction is going to the large PK. And the last one, you do the same thing. You just take a look of your PK and decide which side the reaction is gonna go. So we have 15 and 36. So straightforward, the reaction is going that way. So does that make sense? So far, so good. So pay attention. Remember that small Ka means large PK. Because if they only give you, instead of PK, they give you Ka, you may be confused. But it's the same thing, so you have to remember that. So they ask us to draw the missing resonance structure of a phenoxide and 4-nitrophenoxide. This is his one because I think you did this in chapter 16 for your exam. It was question like this. So what happened here? So how can you put our narrow to go from this structure to the other one? It's just a redistribution of your electron. So you put, let's say we put the narrow this side, right? This gives us this structure. And then from here, what is the next move? How can you move around the electron? That's the question you have to ask yourself. So let's put those electrons here. What if I move this one to here. So that will be the structure. We draw this one. Let's see. This is moving there. We'll have double bond here. Does that make sense? And then we have this bond here, and the electron is going to be somewhere. We can put minus sign. So and then you ask yourself, what is the next direction of you moving the neuron around? So let's say this bond is going this side, and this one is coming here. So what structure going to be? We draw this one this way. Does that make sense? And then what will be our next move again? Let's say we move this one around here. This is going this way. Does that make sense, guys? And if you move this one around, we come back to our first structure. Does that make sense? It's just the way you moving your electron or your neuron around. And for the next one, we will do the same thing. So to go from the first structure to the second one, we just move our neuron, our electron around. Again, we do the same thing. We bring this one down here. It's going this way. Does that make sense? And then we do the something like we did a moment ago. Again? Yeah. And then we move again this narrow around. Let's say we move this one around here. This is going that way. Oh, okay. Oh, this one, yeah, I see. Okay, I see that. In the next one, yeah, I see. Oh, okay. Yeah, I see. And then this negative can move here. This one's going here. I didn't. Yeah. This one. Okay. Yeah. Okay. Oh, okay. Does that make sense to everyone? Online, guys, any question? Okay. So, second question, they ask you to give the product. So we have this reaction, how we call this? Oxymercuration, demercuration. So the thing you have to keep in your mind, the first of all, you have to know that this reaction is follow Markovnikov rules. And then also is anti-selective. So if you have those in mind, you can easily draw your product because you know is going through anti-selectivity. So the product will be oxygen and OH here. So but hydroboration is a different way. It's giving you anti-Markovnikov rules and is scene selection or scene selective. So your product will be something like this. You have your H here, and you have your OH here. So that's the thing you have to keep in your mind. You have to separate them. One is going through syn addition, hydroboration going through syn addition, and giving you, the other one is giving you anti-addition. So far, so good. So how about the second one? We know that diodes can be prepared from opening of epoxide. So from this compound, metachlorobenzoic acid, we getting this epoxide, and then make sure it's not only H3O plus, it's also all around. So what will be your product? You open up the O-rings. Does that make sense to you? Yes, ma'am. The mechanism for what? Yeah. So let's make it simple. We have this this is your compound, and your migration gonna happen this way. So you have OH. So what is your next step? What is happening is your double bond gonna attack somewhere, and one group is leaving, right? And the next one, we will have this compound, SFA plus HCO minus. Right? And then, as I said, we also have OH. OH is going to attack the bond, and this time it will be SN, SN or SN2 attack. So OH is going to attack from the back side, and then you move from the back side, from the top. Does that make sense to you? Do you see what is happening? Okay, and then your water cone attack 1H here. So that's keeping your mind. Acidic is sin addition. I can say that. The other one, this one is a sin addition, and you keep your stereochemistry. But for this one, it collapsed a little bit because of the attack from the backside. Okay, that's another question from page 23. So the easy question, they ask you which reagent can you use? So if you did go through your note, they say somewhere like NBH4 is good for what? For aldehyde and the ketone, right? But when you go to carboxylic acid and ester, NBH4 is not strong enough for deprotonation or oxidation. So this time we don't use only NBH. This time we have to go through lithium aluminum, because this one can easily reduce carboxylic acid and esters. So with that in your mind, you have to ask yourself, which reagent should I use to reduce the first product? So you have to make sure, what is this? You have to know the functional group. And in this case, with what I just say in mind, you can see that both reagents can reduce the compound, right? Yeah. And the next one, because is ester, we know that NADH4 cannot reduce ester. So it is quick that only this reagent can reduce the compound. The next one is a carboxylic acid because of the OH group there. So only lithium hydride can reduce the compound. So how about the last one? Is aldehyde. So we know that NADH4 can easily work with aldehyde. So that means both reagents can be used to maintain the reactions. So does that make sense? So you just have to make sure that you understand which reagent should I use. So if it's a aldehyde, carboxylic acid, esters, or ketones. So with that in your mind, you can easily answer the questions. Any questions so far? Okay, the next questions. They ask you to fill in the missing reagent on the right or product on the left for the following. So how can you fill up this one? So you have to make sure in your, first of all, this is Grignard reagents, and how Grignard reagent add or attack carboxylic. That's the first thing you have to keep in your mind. So with that, you can easily answer the question. So what will be the missing compound here or reagent to have the product? That's how you have to ask yourself. First of all, you have to draw your carboxylic here. And then we know that we have OH. And, okay, keep in your mind like this. We have RMDBL with carboxylic. The R is attacking, we will have OH and R. So it's the same thing. So your R is this benzylic group. So what will be your reagent? So we will have H here, H there. Does that make sense? Because if you attacking this, easily you have your, let's say you have H here, or H. Sometimes it's the way of representing things that can confuse you. So you have to make sure there is H here because carbon is always tetravalent. So you have to have 4 elements attached to your carbon. So does that make sense? So the next one, simple epoxide. So the third one is similar to the first one. As you can see, the only difference is instead of HH, we have CH3, CH3. So you have the same compound, CH3, CH3. Does that make sense? Because we will have H somewhere here, which we don't often represent, but put in your mind that there is H somewhere. So you have your carbon, you've got 4 elements attached to it. Any questions so far? Okay, so the next one, the first thing you have to have your structure, because this is just a name, they're telling you acetophenone. So what is the structure of acetophenone? That's the first thing you have to figure out. That's my acetophenone. And to that, they adding ethyl quinone. So what will be your product? Now, this time they ask you to fill up with the product. So what will be the product of the reaction? So we drawing our compound. Does that make sense? Benzaldehyde, what is that? So we draw the compound of benzaldehyde, what? Yeah, benzaldehyde. So what will be your structure? That's first of all, you have to go from name to the structure. So we draw our structure. Again, the same thing, I'll be our product. Does that make sense? The next one is 2-pentanone. So we just came from naming our compound. So we know penta mean 5 carbons. So we have 1, 2, 3, 4, 1, 2, 3, 4, 5. Since it's a second position, the O will be something like this. So what will be the product of the Grignard reaction? So we draw our compound OH. The next one is the same compound, but this time is in the third position instead of second position. So let's draw your compound. One, two, three. 1, 2, 3. So that will be our compound. And then you do the reaction. We have OH. Does that make sense? Online, any question? Okay, so that'll be our last question. They ask you to show the product of the reactions. So I'll be the product of the reaction. Is almost the same thing, but this time we have ester, and we have 2 equivalent of Grignard reagents. So that means we have 2 substitution, right? So our product will be something like this. Right? Does anyone see that? They ask to draw all the product. You can stop by, or you can add, since this group is leaving, and we can draw also something like this. Do you see that? So the next one, this is a kind of a ring opening. So we have this compound. We just draw the compound the way it is. I mean, we draw here. Does that make sense to everyone? So no question so far? Is what? I didn't get that. Yeah. Do you understand the first one? The first one, you understand the first one? Yeah, that's what I mean. If you understand the first one, you understand using the second, because this is an opening. Since this one is leaving, right? This one is now where to go. You have right? Because you can know this one easily, the OH here can go, but this one can grab the O can grab the H from O somewhere, and then you have Okay, if you guys don't have questions, I think we done for tonight. And thank you for coming. Any questions so far? Getki, we pause, we stop. So do we stop or pause the let's stop?
Yeah. No, you just end the meeting.
You don't stop the video?